Let's go over some simple equations and the 3 tips that I remind myself to help me when solving for x. The 3 steps that I take typically are: first, eliminate any fractions, and you can eliminate those fractions using the LCD. So we'll practice that today. Another step you want to remind yourself is to always combine like terms. That's going to involve anything with a letter in it as well. We want to knock those out and combine those if we can. Furthermore, opposites. It's always the rule of opposites when you're solving for an equation. That's going to be, if you have a +4, you're going to want to do -4 to both sides. So let's see how these things work with some actual math problems. Let's say we have 4x plus 7 equals, let's just say 14. Nothing too crazy so far. So for a lot of people, what a lot of students do is they start to randomly plug in numbers for the letter x to see what value will work right off the bat. But sometimes the answer might be a little bit too difficult to think off the top of your head. There's a surefire way to solve for x, and this is how you do it. This is the process. You want to first isolate the term with x in it, and sometimes that has a coefficient. The coefficient in this case would be the 4. Don't be intimidated by that, okay? We're going to take this one step at a time. You want to isolate that term first. That should be your first priority. We don't have any fractions, by the way. Notice how I'm skipping that for this first problem. So in order to do this, we have to move the 7 to the other side. To move that 7 to the other side, we have to do the opposite, and that would be the -7 on both sides. So that's the rule of opposites that I mentioned. We're talking about the opposite operation. We know that with multiplication, it's going to be division. With addition, it's going to be subtraction, and vice versa. So be very comfortable with remembering that. We're gonna have 4x equals 7. And now we have to tell ourselves, how can we get rid of that 4? How can we actually separate the 4 from the x? What a lot of people forget is there is multiplication happening between the 4 and the letter x. It's not going to be shown with the operation, but when you have the number and a variable touching, that's basically multiplication. So the opposite of that, as we just went over, is division. So what we have to do is divide both sides by 4. And you can show that with either a fraction bar, or you could draw the division symbol. I like to draw a fraction bar. So what happens is the 4's will cancel, and on the right hand side we're left over 7 over 4. We've officially solved for x, and there's no plugging, no guessing, no pondering or brainstorming. We just follow these rules and we can solve for the variable every time. Let's do another one. All right, again, one x term. You want to identify how many x terms there are, because that's going to tie into the combined like terms that I mentioned. We only have one, which is great, but we do have a fraction this time. So before we try anything else, how about we get rid of the fraction? Now, the order of these steps, they can kind of be interchanged, but for me personally, I can't stand fractions. I personally want to eliminate those first. That's my personal priority. That helps me out. And the way we do that is by finding the LCD of the entire equation. So out of this entire equation, thankfully, we only have one fraction. So the LCD is easy. The LCD is just 2. That's the least common denominator. Least common denominator. In other words, what is the smallest number that every single denominator goes into? Again, it's easy because we only have one fraction this time. So to properly eliminate the fraction, we have to multiply the entire equation by the LCD. So we're going to get 1/2 x plus 3 equals 5, all multiplied by 2. I'm showing parentheses to show multiplication. Remember, this 2 is going to be distributed to every single term. So in that first term, the 2's cancel, and we get x. That was our goal. That's why we did this step. Then we have 2 times 3, that's 6, and then 2 times 5 is 10. My final steps are going to involve opposites. I have to get rid of the 6. I want the x by itself. I could get rid of the 6 by subtracting 6 to both sides. I know I have to subtract because it says +6, and the opposite of plus is minus, right? So we have x equals 4, and that's our final answer. Let's try one with multiple fractions. Actually, before we do that, let's practice combining like terms. I want you guys to see what happens if we have x on both sides of the equal sign. So we have 7x plus 3 equals 5x minus, let's say, 13. All right, so understand we have two x values. We have two x terms here. One of our goals is to combine those. That was the combine like terms step that I mentioned. Don't be intimidated by moving a term with a letter in it. It's the same rules with opposites. You see, that's going to tie into each other. All right, so in other words, how would you move the 5x to the other side of the equal sign? Because our goal is to take this 5x and transfer it over to the 7x. So what would you do? If you said add 5x to both sides, you would be wrong. What you have to do is you have to subtract. You have to subtract 5x to both sides of the equation. It would look like this. Now when we combine these, we just combine the coefficients. So we have 2x plus 3 equals negative 13. From here, we follow the same steps that we've been practicing. I'll subtract 3 to both sides. We get 2x equals negative 16. Divide both sides by 2. And we get x equals negative 8. Don't get caught up when you see x on both sides of the equal sign. You can combine those just like any other number. All right, now let's have some fun. Let's practice some fractions. Let's throw in some multiple fractions into this equation here. Say we have 3/2 plus x over 4 equals x over 8 plus 2. All right, so I threw in three fractions. I'm taking quite a big step up. So follow along here. My first goal, personally, there's a couple options with what we can do here realistically. If you wanted to, guys, you could subtract 2 to both sides if you really wanted to. But if you do this, you'd have to subtract the fraction minus a whole number, which is possible. I feel like that's just wasting time, though. We could eliminate all the fractions in our first step. So the LCD is going to be what? It's the number that goes, it's the smallest number that each of these denominators go into. Incidentally, the LCD is 8. Whenever you're unsure of an LCD, you can always multiply the two largest numbers in the denominator, and that will be a denominator that you could use to multiply across the equation. So 4 times 8 would have been 32. I could just take 32 and multiply that across the entire equation, but that would entail some further simplification that I would only use as like a last resort. If you're stuck on finding the LCD, that's a great thing to have in your back pocket. It's a great skill to have in your back pocket and use in case of emergency. Okay, so we know the LCD is 8. We're going to multiply this whole equation by 8. Now, when I multiply the 8 across, some people would put 24 over 2. Technically, the 8 does multiply to the top of a fraction. The whole number multiplies to the top of a fraction. But if you want, you could skip that step and simply cancel out whatever's top and bottom. Since we have multiplication, we could cancel out the 8 as our first step. That's just a personal preference. With larger numbers, this becomes very helpful. All right, continuing. So we're going to get 4 times 3, right? So that first term is just going to be 12. Okay, so 3/2 becomes 12 after we multiply it with 8. Furthermore, we're going to take the 8 and multiply it to the next term over. That's going to give me 2x. Because 8 divided by 4 is 2. And the 2 is what's remaining. I still need to multiply that to the top. So 2x. Then we have 8 times x over 8. In that case, the 8's cancel. We just get x. Our last step is 8 times the plus 2. So that's plus 16. Now we're looking a lot better, in my opinion. I feel like without the fractions, this becomes a lot easier. I know I have to combine like terms. I'm going to subtract x to both sides. And then after that, I'm going to subtract 12 to both sides. So when we subtract x, we get 1x. Now we don't have to draw that 1, okay? It's just invisible. So it's just going to be x. And then we have to subtract the 12, and that's going to give us a positive 4, and that's our answer. A quick little bonus tip to finish off this video. If you're not sure about your final answer when solving for an equation, there's a way to check if your answer is correct or if it's wrong. If it's correct, you could plug it back in and you're going to get the same number on both sides. Let's see what that looks like. So if we plug in 4 for every x value that we see, we get 3/2 plus 4/4 equals 4/8 plus 2. So far it doesn't look like the same number, but let's finish this up and combine and simplify. We have, instead of turning 4/4 into 1, I'm actually just going to turn 3/2 into 6/4. I have to multiply the top and bottom by 2 to make the denominators match, because now we are combining fractions. 6/4 plus 4/4 equals 4/8 plus, what I'll do for the 2 is I'm going to multiply that by 8, top and bottom. So that's going to give me 16/8. To continue on the left-hand side, we get 10/4 equals 20/8. Now I have to simplify each of these fractions. 5/2 equals 10/4, which is equal to 5/2, right? So turns out when we plug in 4, we get the same value on each side. Now what made this a little bit more difficult is all the fractions. I have another video on fractions on my YouTube channel, so if you need help with that, go check that out as well. But in terms of solving for an equation, we're done. We've covered up some important techniques, and we checked how to check our work. We checked how we could verify if our answer is correct or if it's wrong. If it's wrong, you would have gotten 2 different numbers, like 5/2 equals 3, for example. All right, thanks for joining, guys. Any suggestions? Leave a comment down below. I appreciate the support. Subscribe for more free math content, and have a great day.